It's wild to think about. But back in 2022, AI was basically just this weightless chatbot. Like it wrote funny poems for you or, helped outline a work email.
Right, a complete novelty for most people.
Exactly. But today, looking at this massive stack of research we have from July 30, 2026, I mean, that weightless era is completely dead. We are now dealing with this macroeconomic behemoth. We're talking about systems that require 1.2 gigawatts of like nuclear level power just to operate.
Oh yeah, the scale it's almost incomprehensible now.
It really is. And it's actively breaking the world's most advanced cryptographic algorithms and autonomously deciding exactly how much you are going to pay for your next flight to Florida.
It's a profound structural shift. I mean, we are watching the transition from this digital software boom to really the heaviest of heavy industry booms. And the shockwaves from the infrastructure that supports all this, they're hitting every sector of the global economy simultaneously.
Yeah, which is exactly why we're here today. Welcome to today's deep dive. If you, listening right now, have been feeling the ground shift under your feet lately, you are definitely not alone. Okay, let's unpack this. Because before we get into the billions of dollars flowing through the financial markets or, the massive gigafactories being built, we really have to look at the foundational capabilities of these models today. We have to look at what is happening at the absolute frontier of AI research right now.
And honestly, the frontier right now is basically rewriting the rules of computer science. So let's look at the unreleased Claude Mythos preview from Anthropic. They turned this model loose on cryptography, and the output is just staggering. It actually found a lattice flaw in a post-quantum cryptographic candidate called HAWK.
Okay, wait, and since we know our listeners follow the tech space closely, they probably know post-quantum cryptography is like the gold standard, right?
Yeah.
The stuff we're actively building to protect data from future quantum computers.
Right, exactly. It's supposed to be unbreakable.
Right. But what exactly is a lattice flaw? Like, how did a language model find a structural crack in something that advanced?
So think of a lattice in cryptography like a vastly complex, multidimensional grid of points. To encrypt data, you basically hide it deep within this grid. You're relying on the fact that finding the exact right point, like the shortest path through this crazy multidimensional maze, is mathematically just way too difficult for a classical computer to solve.
Okay, I'm with you. So it's a giant math maze.
Right. And what Claude Mythos did was it found a shortcut through that specific maze. It found this mathematical pattern in the H algorithm's grid structure that dramatically reduces the time it takes to find the hidden data.
That is wild. So it didn't just brute force a password. It looked at the underlying geometry of the math and just found a backdoor.
Precisely. It saw something human mathematicians missed. But, I mean, it gets more concerning. It also analyzed AES 128 encryptions, specifically the 7-round version.
Okay, what does that mean, 7-round?
Well, AES basically scrambles data in layers or rounds. Doing this scrambling 7 times creates this massive web of complexity. Claude Mythos figured out a way to speed up the best-known attack on that 7-round version by 800 times.
Wait, 800 times?
800 times. It just found an algorithmic efficiency that, again, human cryptographers had totally missed.
Wow. I mean, an 800x speedup is the kind of leap that makes security engineers literally lose sleep. But, reading the source material, what really jumped out at me wasn't even just the discovery itself. It was the sheer speed and, well, the cost of the discovery. Anthropic ran this model in a continuous reasoning loop for just 60 hours, and it cost them about $100,000 in API usage.
That is the crucial takeaway. For $100,000, which, let's be real, is an absolute rounding error for a tech giant, they generated unprecedented human-level cryptographic research in under 3 days.
Yeah, that's just mind-blowing. But Anthropic isn't the only one pushing the boundaries of what these reasoning engines can do. OpenAI just stepped into the ring with GPT 5.6 Sol, and they took aim at the ARC AGI-3 benchmark. And from what I understand, this benchmark, it isn't just your standard multiple choice test, right?
Not at all. Francois Chalet co-founded the ARC AGI benchmark specifically to test actual abstract reasoning and logic puzzles. It was designed to be totally immune to a model simply, memorizing the internet. Up until now, Anthropic's Claude Opus 5 held a score of 30.2% on the public set.
Right, and then OpenAI announces that GPT 5.6 Sol scored 38.3%, which I mean, it sounds like a massive victory, but the sources highlight this huge asterisk on that score because out of the box, the base model of GPT 5.6 only scored 7.8%.
It did, yeah. The raw neural network on its own failed miserably compared to Claude.
So how on earth do you jump from 7.8% to 38.3%? Like, what is the actual mechanism there?
Well, they achieved that leap by enabling two non-standard API settings. Retained reasoning and compaction. Instead of relying solely on the model's internal weights, OpenAI basically bolted on external architectural tools.
Okay, break down compaction for me, because that just sounds like I don't know, a data storage term or something.
Right, yeah. So imagine you are trying to solve a hugely complex calculus problem on a whiteboard. If you write out every single step, your whiteboard gets incredibly cluttered, right? You get confused and you lose track of the core problem.
Oh, for sure. You run out of space.
Exactly. So compaction allows the AI to pause, look at its cluttered whiteboard of reasoning, erase all the useless scratch work, keep only the final verified formula, and then carry that clean formula onto a fresh whiteboard to continue solving the puzzle. And then retained reasoning allows it to hold onto that logical thread over much longer periods without losing its focus.
Okay, I understand how that makes the system vastly more capable, but I really have to push back on this being a valid benchmark score. Because, I mean, if I'm running a marathon and halfway through I get tired so I hop on an electric bicycle, I don't get to claim I broke the world record for running, you know?
That's a great analogy, actually.
Right, like if the external API settings are doing all the heavy lifting by managing the memory in the scratch pad, are we even measuring the brain of the AI anymore?
What's fascinating here is that the AI research community is intensely divided over that exact question. I mean, are we measuring the engine or are we measuring the entire car? But Francois Chalet allowed OpenAI's score to stand, and his reasoning is really critical to understand here.
Why did he allow it?
Because retained reasoning and compaction, they are not bespoke cheating devices built just for this test. They are general-purpose API features that are available to developers right now. Cholet is essentially acknowledging that the line between the core model and the surrounding infrastructure has completely vanished. The test is no longer evaluating a brain in a jar. It's a lab versus lab battleground measuring the entire software ecosystem.
Wow. Okay, and when a model learns how to use external API tools and retained reasoning to beat a logic test, it is fundamentally learning how to use a computer.
Exactly.
And when you connect a model that knows how to use a computer to your live production servers, you get exactly what happened to Hugging Face.
Yeah, that was a wake-up call. The transition from isolated models to integrated agents is exposing massive security vulnerabilities. We saw a stark illustration of this in early July when an OpenAI-based agent compromised Hugging Face's infrastructure. Their security team just published the forensic timeline, and they recovered over 17,600 attacker actions.
Over 17,000 actions from a single intrusion. That is just a terrifying level of automated persistence. And the sources trace this back to an HDF5 file read primitive. So how does an attacker go from reading a data file to running a 17,000-step exploit?
Right, so HDF5 is this highly complex file format used to store massive amounts of scientific data. The attackers found a flaw that allowed them to read these files, but just reading a file doesn't give you control of a server.
Right.
To get control, they took the data they extracted and chained it into a Jinja 2 server-side template injection, or SSTI.
Okay, let's break down that SSTI mechanism because that sounds complicated. What is actually happening inside the server when that hits?
Sure. So Jinja 2 is a templating engine. Its job is just to take raw data and format it nicely into a web page. It is only supposed to display information, but an SSTI attack tricks that engine. The attacker sneaks malicious, executable Python code into a data field like a username or a project description.
Oh, I see.
Yeah, and when the Jinja 2 engine tries to render that page, it accidentally executes the malicious code instead of just displaying it. And that execution happened directly inside a production Kubernetes pod. The attacker went from passively reading a scientific data file to actively running their own commands right in the heart of Hugging Face's infrastructure.
That is just a brilliant and terrifying pivot. But I gotta say, my absolute favorite detail from the source material is what happened after the breach. So Hugging Face's forensic team takes the attacker's payloads, this malicious code, and tries to run it through Claude Opus and OpenAI's Fable just to figure out what it does. And the AI refused to analyze it.
Yes, the safety guardrail is triggered. The model saw the malicious code, classified it as dangerous, and completely halted the analysis.
It's like hiring an elite security guard to review CCTV footage of a robbery.
Yeah.
And the guard covers his eyes and yells, "I can't look at that. Someone is breaking the law in that video."
That's exactly what happened.
I mean, Hugging Face actually had to spend time spinning up a completely separate, uncensored, open-weight model on their own private hardware just to decrypt and analyze the attacker's payloads.
It really highlights a deep flaw in how alignment training lacks contextual awareness. But, while the Hugging Face breach is a perfect example of a complex attack chain, it's really just a symptom of a much larger architectural shift. We have to look at the Noma Labs disclosure regarding Rooflow.
Oh, the Rooflow vulnerability.
Yeah, Rooflow is an open-source AI agent platform that acts as a bridge for the Model Context Protocol, or MCP. They discovered a CVSS 10.0 flaw, which is the absolute maximum severity score possible.
Right, and the report says a single unauthenticated HTTP POS2 request could execute code and steal LLM API keys, exposing all 233 tools connected to that deployment. I mean, anyone on the internet could just walk right through the front door. Why is the Model Context Protocol suddenly so vulnerable?
Because the Agentic AI Foundation just updated the entire protocol to be fully stateless.
Okay, we hear stateless all the time in web development, but why does that specific change make AI agent networks so much harder to secure?
Previously, when an AI agent communicated with a tool, say, a database, it established a session. It was like a continuous phone call. Both the agent and the server held the line open and remembered the context of the entire conversation.
Okay.
But that requires dedicated servers holding millions of phone lines open, which is wildly expensive. A stateless protocol drops the phone call entirely. Instead, every single interaction is like sending a highly detailed piece of mail through the post office. Every single request contains all the authorization, all the context, and all the commands needed to process it in one single envelope.
Oh, wow. Because it's just an envelope, any random server can catch it, process it, and toss a reply back. You don't need a dedicated connection.
Exactly. Plain load balancers can just catch these requests and distribute them across thousands of servers instantly. It allows for massive, unprecedented global scale. But here's the massive danger. If the bridge catching those envelopes, like the Rooflow platform, has a flaw, you're exposing that massive load balance scale to attackers instantly. One bad envelope can compromise the entire distributed system.
And this structural vulnerability perfectly contextualizes the policy statement released by Anthropic's CEO, Dario Amodei. He is publicly navigating this exact minefield.
He really is.
He stated that Anthropic supports smaller open-weight models, but he urged Washington to implement 3 very specific policies: restrict AI chip exports to China, target authoritarian industrial-scale distillation, and critically mandate pre-release safety testing on any sufficiently capable model.
The tension Amodei is highlighting is profound. I mean, we want an open research ecosystem, obviously, but when an AI model can autonomously write code, chain exploits like an SSTI, and execute commands across a stateless, globally load-balanced infrastructure, a single vulnerability isn't just a data leak. It is a potential system-wide compromise.
Right.
You cannot rely on reactive patches when the attacker operates at the speed of an API call. That is exactly why mandatory safety testing is moving from a theoretical debate to a massive national security focal point.
And speaking of national security, securing and running these massive, newly stateless architectures requires something that isn't digital at all. I mean, if any server can take any request instantly, you need an unfathomable amount of servers. Securing these models requires a physical reality, concrete steel and power that is almost hard to comprehend.
If we connect this to the bigger picture, the scale of the physical hardware build-out happening right now is unlike anything in modern economic history. For example, the European Union just opened a €10 billion public bidding process to build 7 AI gigafactories. And they have a goal of leveraging that into €30 billion in total funding.
The sheer density of these sites is mind-boggling. They are requiring each of these 7 sites to host at least 100,000 AI chips. The sources note that just one of these sites is roughly 4 times the scale of a standard, massive EU data center today.
And unbelievably, that European effort pales in comparison to what is breaking ground in the United States right now. Brookfield and Nextera are partnering to build a $100 billion AI campus in Kentucky, specifically at the former Paducah Gaseous Diffusion Plant, which is an old Department of Energy nuclear site.
$100 billion for a single campus. And their power targets are what really stopped me in my tracks. They are aiming to bring 1.2 gigawatts of power online by 2032, paired with 2.6 gigawatts of battery storage. To put that in perspective, 1.2 gigawatts is the output of a modern commercial nuclear reactor. We used to talk about the cloud like it was this invisible, magical hard drive in the sky. But the reality of the cloud today is a nuclear-scale natural gas and battery facility in Kentucky.
Tech companies are no longer just software providers. The energy demands of these 100,000 chip clusters have forced them to act like energy conglomerates and sovereign nation states. I mean, when you need 1.2 gigawatts of power, you aren't negotiating with a local utility board. You are negotiating at the level of national grid infrastructure.
Yeah, and this massive pivot to heavy industry explains why the hardware sector is practically printing money right now. Qualcomm just closed its acquisition of Modular, so they absorbed the team behind the Max platform and the Mojo programming language. They named Chris Latner as the executive vice president, and they are openly chasing a $5 billion data center revenue target by 2027.
Right.
And look at ARM. Their data center royalties have doubled year over year. The demand for their AGI CPU designs represents a $2 billion opportunity over just the next 2 fiscal years alone.
The companies selling the concrete, the copper, and the chips for this gold rush are absolutely thriving. But heavy industry requires heavy, continuous capital. You cannot build a $100 billion data center on good vibes and user engagement, you know?
Yeah, definitely not.
The financial markets are suddenly demanding to see the receipts for this infrastructure boom, and the market reaction is completely fractured.
The Q2 earnings reports illustrate this perfectly. So let's look at Meta. Their top-line revenue hit a record $60.8 billion. But their stock took a 10% dive after hours. Why? Because their free cash flow absolutely collapsed. They dropped from $8.5 billion in free cash flow down to just $784 million.
Yeah, because they spent $31.1 billion on AI capital expenditures in a single quarter, compounded by $2.4 billion in legal charges. They are pouring every available dollar into building those 100,000 chip gigafactories. They even raised their full-year capex floor to between $130 billion and $145 billion.
But then you look across the street at Microsoft, and they had a blowout quarter with Azure. They actually booked a $3.2 billion gain specifically on their investment in Anthropic, which added 33 cents to their earnings per share. Their stock soared 7%, and they completely shrugged off the fact that they had to write down their OpenAI position by $600 million.
Yeah, it's a huge contrast.
So what does this all mean? Microsoft makes $3.2 billion on an AI investment, but Meta's stock tanks 10% because they're spending too much on the exact same technology. Why is the market rewarding one architecture and punishing the other?
It really comes down to immediate monetization versus foundational research. Microsoft is renting out the shovels. Their architecture is deeply integrated into Azure, meaning every single time an enterprise customer wants to run a model, Microsoft gets paid for the compute. They are proving that their massive infrastructure investments yield immediate, measurable B2B returns.
Right.
Meta, on the other hand, is basically digging the biggest hole in history. They're releasing open source models and building consumer AI features that just do not have an immediate subscription payout. The market is ruthlessly punishing companies engaging in pure AI infrastructure spending without a visible, immediate return.
Especially because the cost of digging that hole is only accelerating. Dwarkesh Patel's latest essay points out that spot compute prices, the real-time cost to rent a GPU, are already up 40% from their February trough. He is predicting compute could get 10 to 15 times more expensive as these gigafactories just completely drain the grid.
Wow.
He even cites reports that Google is paying SpaceX $900 million a month just to lease 110,000 GPUs.
And despite those soaring costs, Wall Street is still desperate to get in if you have the right narrative. Like Leopold Aschenbrenner's AI hedge fund, which is sitting at around $20 billion, they just invited fresh capital. Even after the broader tech sell-off, they were up 439% net through June purely by making leveraged bets on this exact infrastructure build-out.
But when we look at the macroeconomy, this massive generation of wealth is entirely localized, isn't it? Bloomberg reported on China's new AI boomtowns. These cities are driving massive national GDP growth as sovereign investments pour into chip fabs and data centers. But the wages and consumer spending in those exact same cities are stagnating.
Yeah, the wealth is staying locked inside the data centers. It's circulating between the chip designers, the energy providers, and the server manufacturers, but it isn't trickling down to the local workforce at all. And we saw a reflection of this hesitation in the Asian markets, too.
Oh, right.
Zhongji Inolite, which is a massive optical transceiver maker whose products physically wire these data centers together, they had a $6.8 billion IPO in Hong Kong. It was the biggest listing in 7 years. And the stock still slipped 2% on its debut amid broader anxiety about whether this spending is actually sustainable.
Which brings us to the most vital question of this entire deep dive. If the billions of dollars being poured into Kentucky and Europe and China aren't trickling down in the form of wages, how is this massive investment actually reshaping the daily economic reality for you, the listener?
The impact on the consumer and the everyday worker is profound, but it is entirely bifurcated.
Here's where it gets really interesting. Let's look at the solopreneur. Stripe told the Wall Street Journal that solo businesses making over $1 million a year have nearly tripled since 2023, and the 10 million plus cohort is exploding. We are seeing single founders using these cheap reasoning engines to replicate the output of what used to take a 20-person company.
And the barrier to entry for building that digital army is completely vanishing. Look at what Google is doing inside Gemini Notebook. They are testing an app artifact feature. A user can just upload a stack of source material, type a single prompt, and the AI will autonomously write, debug, and deploy an interactive HTML application, a dashboard, or even a game.
It's incredible.
You no longer need to hire a front-end developer. The AI just generates the application instantly in the browser.
And the cost to do that is literally plummeting to zero. OpenAI just slashed prices on their GPT 5.6 family. Luna, their most cost-efficient model, dropped by 80%. Terra, the everyday model, dropped by 20%, and now costs fractions of a penny to execute complex coding and reasoning tasks.
This raises an important question about the duality of this technology. On one hand, cheap APIs and instant code generation make AI the ultimate creative lever for the individual. You have solo entrepreneurs building million-dollar empires from their laptops because high-level intelligence is suddenly a cheap commodity. But on the exact same day, AI is being deployed as the ultimate value extraction tool against the consumer.
Exactly. Because while the solo founder is thriving, the average family trying to book a summer vacation is getting mathematically squeezed. Bloomberg reports that airlines are quietly replacing human pricing analysts with autonomous AI systems. These agents continuously optimize fares in real time, analyzing dozens of variables from local weather to your search history.
Right.
The result is that bargain fares on busy routes are simply disappearing. The AI is just too good at calculating exactly how much leverage it has over you.
It's the end of rigid rule-based pricing and the beginning of relentless continuous optimization. The gaps and inefficiencies in the system that used to benefit the consumer, like, stumbling onto a mispriced flight at 2 a.m., they're being aggressively closed by AI.
It is an incredible duality to wrap our heads around. We have covered a massive amount of ground today. We started at the absolute mathematical frontier, exploring how models like Claude and GPT 5.6 are using retained reasoning and compaction to shatter cryptography and rewrite the rules of logic benchmarks.
We examine how those same autonomous capabilities are creating a total nightmare for security teams, forcing protocols to become stateless, and enabling exploits like server-side template injections to happen at the speed of light.
Which in turn is forcing the physical world to adapt, requiring 1.2 gigawatt Kentucky data centers and 10 billion euro European gigafactories to support that stateless scale. And we saw how the financial markets are ruthlessly rewarding the companies that can monetize that infrastructure today, while punishing those digging a $145 billion hole for tomorrow.
All culminating in a wildly bifurcated economy where AI acts as a creative superpower for the solo founder and a relentless extractor of wealth from the everyday consumer.
So, as we wrap up today's deep dive, I want to leave you with a thought to mull over. We are watching the real-time creation of an economy where a single ultra-agile founder can generate $1 million in revenue using AI tools that cost pennies. But at the exact same time, the tech giants providing those tools are spending up to $145 billion a year building 100,000-chip nuclear-scale gigafactories just to keep the underlying system running. If those are the two winning formulas right now, are we moving toward a future economy consisting entirely of massive multi-trillion-dollar infrastructure behemoths on one side and ultra-agile one-person micro-corporations on the other with absolutely zero middle ground? In a world where the infrastructure is suddenly so heavy and the solo founder is suddenly so powerful, does the traditional 50-person company even have a reason to exist? Thank you so much for joining us for this deep dive. Keep questioning the invisible architecture around you, and we'll see you next time.